Hey guys, today we're going to look at this problem. So its rating is 1800, right? As always, we are going to explain the example here. So let's take a look at the example. Um, the first number is the number of test cases we are going to have. So we have three test cases here. For each test case, we are going to have two numbers. The first is A, the second is M, right? So the output is the number of X that satisfy this condition, right? So GCD means the greatest common divisor. So in the first case, GCD of 4 and 9 is 1, right? Which means they are coprime, right? And how many x are there to satisfy this condition? So we can try, right? Let's see if x equals to 0. GCD A plus X, and the M is still 1, right? Because A plus X is still 4. So apparently, X equal to 0 can satisfy this condition. How about X equal to 1? So we got a 5 here, right? Here is 4 and 9. Let's make it clear. This is 4 and 9, and this guy is 4. Um, this guy is 9, and if we have a 1 here, so we have 5 and 9. The great GCD of 5 and 9 is also 1, so 1 is also satisfy the condition, right? What about the 2? So we are going to have 6 here, but the GCD of 6 and 9 is 3, right? So it's not equal to 1. So 2 is not satisfied. So let's try 3 here. With the 3 here, we're going to have 7 here, right? So the GCD of 7 and 9 is 1. So 3 is good. How about 4? So the GCD of 8 and 9 is 1. 4 is good, right? How about 5? 9 and 9, GCD of 9 and 9 is 9. So 5 is out of picture. How about 6? So 10 and 9, right? GCD is 1. So 6 is okay here. How about 7? 11 and 9. So 7 is good. How about 8? 12 and 9. GCD is 3, right? So 8 is out of the picture. So we got 6 numbers here. So we output 6. That is the number of valid x we can find, right? So the appropriate x are 0, 1, 3, 4, 6, 7. Cool. So we solve the first test case. So how do we solve this problem by writing program? So at the first glance, if you don't have the tools, you may not know how to proceed, right? Have no idea how to solve this problem. But if you have the tools, you can find out a way. So it's not because you are not smart enough to find the solution. It is only because you don't have the tools. So let's take a look at the tools, right? So we have two tools here. First one is Euclidean algorithm, right? This is a formula here. Um, Actually, this formula is used by this algorithm. So we are not going to prove this formula here because you can find the proof in other websites very easily. So we are going to go into the details of the provement. We are going to use it as granted, all right? So for example, if we have A equal to um, let's say 12 and B equal to 8, right? So GCD AB equals to 4, right? And A mod B equals 4, right? And this b is still equal to 8. So what's the GCD of 4 and 8? Is still 4, right? 4 equals to 4. So this formula holds, right? We are going to take it for granted here. So what can we use this? How do we use this tool? So as we can see, the x range is from 0 to m, right? So this guy's range is from a to m plus a, right? So if we use this formula here, that means we can mod this number by m, right? Um, and the that means this let's say we can assign a plus x mod m to t, right? And the what's the range of t here?
Hey, does anybody here want to play a game?
Sorry about that. So um, this guy here, its range is from a to a plus m, right? So this guy here, its range is from 0 to m, right? So we can simplify this formula to GCD t and m, right? So t here is going to be from 0 to m. So in other words, we are going to find the number of t's that equal to this number, right? How can we solve this problem? So the second tool we are going to use is this guy here, Euler's totient function. So this guy means this function is means the number of integers from 1 to m minus 1 that satisfy that is the coprime of m, right? That means the GCD of x and n equals to 1, right? That means x and n are coprime. And how many coprimes is going to be in this range, right? So it can be calculated in this way, right? This is the formula here. So first, we are going to find the um, find its divisors here, right? And in this case, we find the two prime divisors, right? One is 2, one is 3, right? We can ignore the number of times the prime divisor appears, right? And we are going to calculate the number of coprimes by um, using this formula, right? Just move the 2 here and move the 3 here and calculate the factor, right? And we got 12. So this part I copied from Wiki. So you can check out the Wiki page to find out how does this phi function work. So phi function just return a single number that tells us the number of coprimes we can find from 1 to n minus 1, right? So with this being said, we can use this tool, right? So let's see how to use it. Let's clear this page. So previously we already know we just need to find the GCD of T and M that equals to GCD AM, right? Let's say GCD AM equal to little g here, right? So in order to find the number of t's that satisfy this function, we only need to find the number of t's that satisfy this function, right? So if we can make sure these two guys are coprime, that means um, this function is satisfied, right? So in other words, if we um, put this guy as t as d here, right? Let's say d equals to t divide g. Then it means we only need to find the number of d's here, right? So the final problem we are going to solve is GCD of d and m um, divide g, right? So in this case, we can easily solve this problem by using phi function, right? Because we already know this value. M we already know, right? Is here. And G we already calculated, right? So this is a number. And we only need to put this number into phi, right? And we are going to get the number of coprimes of this number, which is exactly the number of d's here, right? And thus, um, by um, multiply it by g, then we can get a t, and the number of t's is equal to the number of d's, right? So that's the way we solve this problem. So as we can see the um, programming here, so the code is quite easy if you understand the math behind it, right? So we just read A and M, and we are going to calculate GCD, right? And calculate t here. So let's see. Actually, m divide g. Um, Actually, I assign this guy to t, so don't be misled here, right? And we are going to um, solve the phi function here, right? I just copy the phi function from the Google, right? So and the same as the GCD function, they're all copied from Google. So you can copy my code as well. So that is a quite a easy code. You don't need to implement it by yourself, right? So I guess that's it. It needs a pretty strong math background to solve this problem. So don't be discouraged. Many programmers are not very good at math, right? So do I. I don't actually very good at math as well. So hope that helps. See you next time.